Okay, so here we go. We're going to go on the 4.2b, part 1. This is just place value in its whole, values of a number, a whole number, not a decimal. So let's start with number 11. Mr. Rodriguez has driven his car 113,103 miles since he bought it. How is this number written in word form? First off, I see a comma here and there's only one, which means the word that I'm looking for, the number that I'm looking for, has to have the word thousand and a comma in it. Okay. This has 1,000 and a comma, yes. This has 1,000 and a comma, yes. This has 1,000 and a comma, yes. And this has the word thousand and a comma, yes. So I can't get over that. I can't go anywhere else, but I am going to look in front of that. That's kind of like a chunking. It tells me, hey, stop. I only want you to look at the three numbers in front and then the three numbers in the back. Okay, so I'm going to look at the first three numbers. As I see that by itself, that number by itself is 113. So that's what I'm looking for, is the words 113. This says 100,000. That means 100. And as soon as I see the word 1,000, that means a comma. Well, that does not match that. 110,000. This means 110,000. That doesn't match what I wrote either. 113,000. Okay, that says 113,000. That's kind of what I had, but I'm not finished reading it. Let's look at D. 103,000. Well, before the word thousand, all I see is 103,000. Well, that doesn't match either. But before I choose C as my final answer, I'm going to look at the other pieces of the number. So I have 113. The comma says 1,000. 103. So I'm going to look at C and make sure that behind the comma, it says 103. 103. Yep, it does. That means C is my answer. Okay. All right, let's look at number 12. Whoa, Haas, slow down. Here we go. All right. Marissa's company made $437,628 last year. What digit, is in the 10,000s place? Mark your answer. All right, so the 4 is in the ones, tens, hundreds, thousands, 10,000s, 100,000s. So the 4 is in the 100,000s. What is this thing doing? Come on. Try this again. Sorry, guys. All right. Come here. So the 4 is in the 100,000s. We're looking for the 10,000s. 7. Ones, tens, hundreds, thousands. That's in the thousands place. This is 10,000s. Boop. 2. Ones, tens. That's the tens place. And the 3. Ones, tens, hundreds, thousands, 10,000s. Okay. I'm looking for the 10,000s place. Well, 4 is in the 100,000th place. That's not my answer. 7 is in the thousandths place. Not my answer. H is in the tens place. Not my answer. 3 is in the 10,000ths place. So my answer is letter J. Okay, next one. Let's go to the next one. Number 13. Oh, okay. This one's going to be a little interesting because it took up the whole page. So, all right, which means I'm going to have to use these down here. Okay, so Miss Martin baked a pan of brownies. Okay, there's no numbers there. That's just information. And she cut them into 10 equal parts. Okay, so I'm going to make sure this is 10 parts. 2, 4, 6, 8, 10. Yep. This one has 10 parts, which means it took 10 brownies to make a whole pan. This one has 10 parts. 2, 4, 6, 8, 10. Okay, finish that part. Miss Hendricks also baked a pan of brownies. Okay, got it. This is hers, Miss Hendricks. And she also cut them into 10 equal parts. I kind of got ahead of myself. I was really going off the picture. So as we go on through the year, you'll find out that when we do big word problems like this, we always attack the picture first. We do everything through the picture that we could possibly do before we ever read the question, because sometimes the picture will give us the answer right off the bat. So she also cut those into 10 equal parts, meaning each pan of brownies, when they pulled them out of the oven while they were still warm, they cut them, and in that pan were 10 brownies. There were 10 brownies to make a whole pan. Okay, that's why 10 is our denominator. Which of the following answers shows the relationship? That means we're going to compare these. So either greater than, less than, or equal to. That's what that means. When we're talking about a relationship between numbers, we're talking about where they're bigger or smaller or equal to each other, how they are the same, how they are different. Okay, so what is the relationship between how many more of Miss Martin's brownies were eaten? So what that tells me is that Miss Martin's brownies were eaten the most. Now here's where the question came in. We were not real sure whether or not they were talking about the shaded part or the non-shaded part, because it doesn't say shaded, which is the shaded part, which is the non-shaded part. It's why it's important to really read into what they're asking. They throw in little words like that that's going to throw us off. What this sentence tells me is that there were more of Miss Martin's brownies eaten. So if we're looking at Miss Martin here, which part is more? The white part or the brown part? Well, she has more white parts. So what that means is the part that was eaten just so happens to be the non-shaded part, which is not what we are used to seeing. We are used to them asking us about the shaded part, but not in this question. We had to use the words inside the problem to determine which part were they talking about, because there's two different questions here. Okay, so we are really looking at the non-shaded part. Okay, so let's look at Miss Martin's. How many of her brownies were eaten? 6 out of 10, yes. Or the whole thing was not eaten. 6/10 were eaten. Those mean the same thing. Okay, now let's look at Miss Hendricks' brownies. Looking at this picture, how many of her brownies were eaten? I'm not asking how many are shaded. Yes, 4 out of the 10 were eaten, which if we were to turn that into a decimal, that would mean the whole thing wasn't eaten, but 4/10 were eaten. Okay, Now, it's asking what is the relationship between how many more of Miss Martin's brownies were eaten than Miss Hendricks. Well, if you're looking at the picture, if we were to draw this out right here, if I was to make this equal, if I was to say this is what had to happen for them to have the same amount eaten, how many more did Miss Martin have eaten out of the pan? She had 2 more. Yeah. So she had 2/10 more eaten than Miss Hendrick. So that's what that looks like as a fraction. And as a decimal, 0 wholes and 2/10. Okay. So we have not looked at the answer choices. This is just the picture and the little bitty tricky information that they gave us at the top. Okay. So now let's go and look at the answer choices. Really? Well, all right. So we need to keep this in mind. 2/10 is what we're looking for. Okay. 2/10 is what we're looking for. So let me clear all the writing. Clear. Clear. Okay. So let's look at the answer choices. I'm going to go back and I'm going to write what we wrote. We know that Miss Martin had 2/10 more eaten than Miss Hendricks. Okay, so that would be that as a decimal. Oh, that was horrible. Clear. Which if I wrote as a fraction, her brownie pan had 10. It would take 10 brownies to make the whole pan. And 2 out of 10 more were eaten. Okay, so let's look at our answer choices. The first thing that I see on my answer choices is they show me fractions first. So that's what I'm going to do my comparison with. You probably hear my dogs barking in the background. All right, so this says 2/10, 2/10. Yes, that works. 2/10, 2/10. Yes, that works. 6/10. Where did 6/10 come from? 6/10 is Miss Martin's brownies that were eaten. But that's not what the question asked. The question asked how many more of Miss Martin's brownies were eaten than Miss Hendricks. If we wanted the answer to how many brownies were eaten of Miss Martin's, this would be the answer. But this is not the difference. This is not how many more were eaten. Let's look at D. 4/10. Where did 4/10 come from? Well, 4/10 is how many brownies were eaten of Miss Hendricks, not the difference between Miss Martin's and Miss Hendricks. So this is how they trick us. The numbers might be there, but the words change the meaning. The words change the meaning. Sometimes we know all the math, but the words get in the way. So we're going to learn this year how to break down those words, see what tricky parts are in there, and how to make us feel more successful, like we are winning the battle, not that question. If this was the war between mathematical people, we are not going to let that question win. We are going to win, okay? So automatically, we have gotten rid of 2 answer choices based on the question, okay? Now we have 2 answer choices left. The fractions matched. Now we're going to look at the decimals, okay? This one has a 0 in front of the decimal, 0 in front of the decimal, 0 in front of the decimal. Ooh, this is the 10th place. A 2 right behind the decimal in the 10th place. That has a 0. That can be my answer. 2 right behind the decimal, yes. So the answer to this question was B. That is a crazy looking bee. All right, we'll let it go. Let it go, let it go, let it go. All right, number 14. We are still on 4.2b, part 1. Okay, I think we have 2 left. That's good. Okay, escape. It says press escape for cursor. All right. Okay, so Lillian paid $61.39 for groceries. The digit 3 in this number has a value, that's important, of. Okay, I see the word and it is in between 2 number words, which means we are using a decimal. Value means how much that is worth. Okay, that's the worth of it. So let's break down this word part. I know that there's a decimal, so I'm going to give myself a decimal in this big open space and work with it. What is in front of the decimal? Well, that's a number word, which means 61. And if I want to put the dollar sign, I can, because that is important. And what is behind the decimal? 39. Okay. All right. So they're asking me about the digit 3. They want to know, how much is this worth? Well, I see it's a 3, but I don't know how much it's worth. If this was money, think of it as money. What would the 9 be? It would be pennies, right? This would be pennies. So this is the pennies, which is also known as the hundredths place. THS at the end, very important. The 3 would mean dimes, right? That would mean I have 3 dimes. So this would be dimes, which is also the tenths place. This is a whole dollar, so this would be 1 whole. And this would be the tens place. Not to be confused with the tenths. Has that THS at the sound at the end. So all I want us to think about is this right here. We have 3 dimes. What would a dime look like as a decimal? Well, a dime means I have no dollars and 10 cents. Yes? Would you say that this is a dime? That this is 10 cents? If I was to ask you just to write 10 cents, yes, that's 3 dimes. This means dimes. Whoop. Sorry, I know that's loud. This means dimes. Okay, so let's hear. This says 3 times 10. Well, 3 times 10 is $30. That's 3 $10 bills. We have 6 $10 bills. That's not an answer. This means 3 1 holes, 3 holes. So that would be $3. Well, we only have $1. So that can't be an answer either. This means 3 pennies. The reason why I know this is pennies is because this is a whole, this is a tenth, this is the hundredths place. Whole, tenths, hundredths place. So this would mean I had no dollars, no dimes, and 3 pennies. Is that what we have? No, we have 9 pennies, so that can't be an answer either. Now, even though I've gotten rid of all the others, I want to make sure that this is the correct answer. I have 3 dimes. 3 times 0 is still 0. Decimal. 3 times 1 is still 3. Now, that doesn't look like money to me because money has 2 digits. Well, remember earlier that there is a ghost 0 there. He is still sitting there. Would this mean 3 dimes? Yeah, so the answer is J. All right, one more. This is probably the longest video. A lot of explaining. Sorry, guys. Number 15. Okay, there's no picture here. It's just a lot of information, but that's okay. We got it. We got it. We're going to think hard about it, and we're not going to let these words mess us up. Now, this word here is a name, Quinlan. If you are reading a word problem and you do not know how to pronounce the name, just call them Q or call them yourself. Put yourself in the story. Christy described a number using these clues. The value, that means how much it's worth, and I see that on all of them, of 7 is 7 times 10. So this means 7 $10 bills. Well, for me, that means if someone gave me 7 $10 bills, I would have $70. I'm going to write that down because that's some good information. The value of the digit 3 is 3 times 1,000. So if someone gave me 3 $1,000 bills, that would be nice. That would give me $3,000. Wow. Okay. And then the value of the 1 is in the hundreds place. So that would mean that someone gave me one $100 bill. Okay. Which number could fit Christy's description? Well, what I see here is that there's no money, there's no dimes, and there's no pennies. So my answer over here, there's money here. There's coins behind the decimal. So what happens here is our brain starts to trick ourselves thinking, well, the answer can't possibly be here because according to what I wrote down, I don't have any dimes or pennies. Well, they might not have given us all the clues. We just have to use what they've given us to find the answer that makes more sense. Okay, so I'm not going to look at the last part of this number. Okay, I cannot let this distract me. All right, so what I see is there should be a 7 in the tens place. All right, I'm going to get my red marker back. There is a 7 in the tens place here. There's a 7 in the tens place here. Oh, no 7 in the tens place there. And a 7 in the tens place there. So I got rid of one answer choice. Now I'm looking for 3 in the thousands place. Well, there's a 3 in the thousands place there. A 3 in the thousands place there. Ooh, the 3's in the hundreds place there. Not an answer. Now I'm going to go find that last one. That last one is hiding. There's a 1 in the hundreds place. That's a 1 in a hundreds place. This one doesn't. The 1 over here is in the money that I marked in the part of the answer that I marked out. So that can't be my answer either, which leaves me with A. All right, that's it for 4.2B, part 1. 23 minutes long. Come back for 4.2C. Bye.